Winter in our YouTube chat wants to know, how will the InSight seismometer be able to map the internal structure of Mars in 3D with just one sensor? How is that accomplished? And Rabbi Cooper over on Twitter follows up, don't we need 2 or 3 to determine the inner composition?
You would think, wouldn't you? Usually if anybody knows anything about seismology, you know that you need at least 3 seismometers to do seismology. And that's true unless you get really clever about it. So we had to get clever. I mean, we actually had lots of concepts of missions that had 3 landers, 4 landers. We even had a concept with 18 landers on Mars at one time. And none of those actually ever got funded because they were very expensive. And so we had to go back to the drawing board and figure out, well, how can you do seismology, real quantitative seismology with a single seismometer? And it turns out there are quite a few techniques that are available to us. I mean, and people have used this on the Earth, but they get sort of eclipsed by the sort of array seismology that we normally do. And one of the things we do on Mars is we use the fact that Mars is small to our advantage. And what happens is that in addition to the P waves and the S waves that you normally hear about in seismology, there's also something called a surface wave, and that's a separate kind of wave that travels along the surface of the planet. And so in addition to the P and the S wave, we actually get the surface wave, which travels to the seismometer, and there's another one that goes the other way around the planet and comes in the long way. And so there's 2 extra, what we call arrivals. And then finally, the one that's gone all the way around the planet can go around again and hit our seismometer, and these things can keep going around. They get a little bit smaller and smaller each time, obviously. So we use that extra information to be able to figure out how far away the Mars quake is, and we can actually use what's called polarization analysis to figure out which direction it's coming from. And so instead of having to triangulate on it using multiple seismometers, we're actually able to use sort of the extra information that's contained sort of later on in the seismogram in order to get the distance and the direction.
Wow.
And it gets more complicated than that, but that's sort of the basic method.
We've got a mountain of questions, Veronica. How much time do we have?
I think we're good. Go one more, and then I'll do a final look in the room here to see if there's other questions. Go ahead.
Okay. Well,